Scatterplots are in this chapter because they're a bunch of random dots. Well, they're not really random. They're dots that show a relationship between two sets of data. And what you can do is you can use a line to predict how it goes in the future, like where the data points would lie. And what we do them is we graph them as ordered pairs. Right, remember x, y. So first, let's just introduce the idea of a scatterplot. Scatterplot shows the amount of grams of sugar and the number of calories in 10 smoothies. So these dots represent 10 different smoothies, and someone measured how much sugar and how many calories are in each smoothie, and they plotted them. So how many smoothies or how many calories are in a smoothie that contains 56 grams of sugar? So you go to 56 grams, you just bring it up to find a dot, and that would be 270 calories. You can also go the other way. How many grams of sugar are there in a smoothie that contains 320? So you go to 320, you find where the dot would be, and you bring it down, and that is 70 grams. That's a lot of sugar. The last question asks you to show something that you notice about a trend. What tends to happen to the number of calories as the number of grams of sugar increases? Well, you can see from the dots that they're going kind of upward. So let's just say that. The number of calories increases as the number of grams goes up. When there is a relationship like that, we would say it was a positive relationship or a positive correlation. You can also have a negative correlation or no correlation at all. So in the one that we were just looking at, the smoothie one, this had a positive correlation because the dots kind of seem to go in a positive direction. You can also have a negative correlation or no correlation. So easier one to recognize is letter B. Letter B has them going down, kind of they're all clustered together going down, and that represents the average daily temperature and the coats sold. So that would kind of make sense, right? Like people buy coats when it's chilly outside. When it's warm outside, people aren't really thinking about buying a coat. So letter B, actually, let's do that one first. That has a negative correlation. Letter A is kind of all over the place. I mean, it goes up a little, then it kind of goes down. But they're very scattered. There's no clear pattern like there is in the calories one up above with the smoothies and this temperature one with coats. So this one, letter A, has no correlation or no relationship at all. A correlation is the word that we use to represent a relationship. So we just saw scatterplots that showed correlations, that they showed a relationship, whether it was increasing or decreasing, positive or negative. When you have that, you can model the trend by using something called a line of fit. And a line of fit is a line that we draw on the scatterplot that is kind of near most of them to represent them in just like one line rather than a bunch of random data points. So the way that you would do that is first you make a scatterplot, then you say, do I see a relationship with these dots? If there is a relationship, then you draw a line that kind of goes through the dots as best as you can. You want to have a balance, so the line shouldn't go through exactly everything. There might be some above the line, some below the line, and we'll see that in a moment. And then once you have the line, you want to write the equation so you can use it to predict things that happen. Let's check out example 3. The table shows the weekly sales of a DVD and the number of weeks since its release. So those are the two labels in my story, the number of weeks and the sales. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line. Remember, interpret means to explain what the numbers mean using the labels in a sentence. That's not new. We did interpreting earlier. So the first step was to just make the scatter plot. So let's make an axis, and if you notice, all of our numbers are in the positive quadrant. So we're going to stick with the positive x, y axes. So that's a big quadrant 1. And I'm going to label with the word. So this is weeks, and this is sales. And I need to figure out what my scale is going to be. So I need to go from 1 to 8 weeks. So that's easy. I can just go 1, 2, 3, right like that. For the sales, it's representing millions. So I need to write that. And my lowest sales is 5, and my highest sales is 19. So I don't think I can go by ones because I don't think it's 19 boxes high. But I could probably go by twos. Oh, perfect. Oh, perfect by twos. So 2 million, 4 million, 6 million, and then I will go all the way up. That would be 20 right up there. So now you just plot your points. So I'll plot the first one. They're all pretty self-explanatory. 119 is right up here. So pause the video, please, and plot the rest of the dots. So then we look and we say, wow, that's really linear. So we can definitely come up with an equation. So what you do is you take your pen or pencil and you want to make it go through the middle of the dots as best as you can. Some dots will be below the line, some dots will be above the line, but you want to keep that balance. So let me see. So let's try this line. It's not perfect. I wish I had a ruler because I'm on the computer. But that has a few dots below the line. It has a few dots above the line, right? This is above. So it's kind of balanced, except, you know, not perfect. I wish I had a ruler. But anyway, so that's the line. Hopefully you're using a ruler or a straight edge because you're on paper. The next thing that you do is you write the equation of your line. So mine goes through 0, 20. I'm picking 2 points on my line, 0, 20, and it goes through here at 5, 10. So that's easy. The b value is 20, 0, 20, and the slope is going to be down 2, 4, 6, 8, 10. So it's down 10. Remember, it's not going by ones, and to the right, 1, 2, 3, 4, 5. So that has a slope of -2. So the formula for my trend line, my line of fit, is -2x plus 20. Now that's my line, my equation. You could have drawn the line just tilted a little more slanted one way or the other. Your intercept might be at 21 or at 19. You might have, you know, a -1.5 slope or something like that. But all of our equations should be pretty much close to each other. So the next thing that we have to do is interpret the slope and intercept. So 0, 20 is going to be the easier one to start with because it's the starting value. So 0, 20 means when the DVD is released, right, like at the start, it sells $20 million. As the weeks go by, they sell fewer and fewer DVDs. So the slope represents that. So -2 means each week, remember slope words are each, every, and per. So it means each week DVD sales go down by $2 million. If you have any questions, write them down and ask me when you come to class.